Welcome. Today, we will explore network authentication, focusing on methods and protocols for secure access. We'll cover various authentication factors, the protocols involved, different security models, and modern authentication solutions. Let's start by understanding the different authentication factors. First, there's something you know, such as passwords, personal identification numbers or PINs, security questions, and passphrase. These are pieces of information only the user should possess. Next, there's something you have, which includes physical items like smart cards, security tokens, mobile devices, or hardware keys. Finally, there's something you are, which refers to biometric identifiers like fingerprints, facial recognition, voice patterns, and retina scans. Now, let's talk about multi-factor authentication, or MFA. MFA is an authentication method that requires users to provide two or more verification factors to gain access to a resource. This significantly enhances security compared to single-factor authentication. MFA greatly reduces the risk of account takeovers and protects against credential theft. It also helps meet compliance requirements and creates a layered defense mechanism. When implementing MFA, it's important to balance security with user experience. You should also consider backup authentication methods and account recovery processes to ensure users can still access their accounts if one factor is unavailable. Now let's delve into password authentication. It's crucial to never store passwords in plain text. Instead, always use cryptographic hashing with Auth. Here's an example of secure password hashing in Node.js using BCRYPT. This code shows how to generate a salt and hash a password securely. For password verification, always compare submitted passwords against stored hashes, never against plain text values. Here is an example. Remember these things to avoid vulnerabilities. Common password vulnerabilities include brute force attacks, dictionary attacks, rainbow table attacks, credential stuffing, and phishing. To mitigate these risks, implement rate limiting, account lockouts, capture mechanisms, password complexity requirements, and multi-factor authentication. Now let's explore some key authentication protocols. First, we have Lightweight Directory Access Protocol, or LDAP. LDAP provides a mechanism to connect to, search, and modify Internet directories. It's commonly used for centralized authentication and operates on port 389 or 636. It is based on X.500. Another protocol is Kerberos, a network authentication protocol that uses tickets. This allows nodes communicating over a non-secure network to securely prove their identity to one another. Kerberos is ticket-based, provides mutual authentication, and is time-sensitive. Remote Authentication Dial-in User Service, or RADIUS, offers centralized authentication, authorization, and accounting, or AAA management for users connecting to a network service. It is a AAA framework. It uses User Datagram Protocol, UDP, and Transmission Control Protocol, TCP, and operates on a client-server model. Finally, OAuth 2.0 is an authorization framework that enables third-party applications to obtain limited access to a user's account on an hypertext transfer protocol, HTTP, service without exposing the user's credentials. It is token-based, provides delegated access, and enhances API security. Let's explore Security Assertion Markup Language, SAML, and OpenID Connect. Security Assertion Markup Language version 2.0 is an extensible markup language, XML, based protocol for exchanging authentication and authorization data between parties. It is an enterprise-focused single sign-on solution that uses XML-based assertions. OpenID Connect is an identity layer built on top of OAuth 2.0. This allows clients to verify the identity of end users and obtain basic profile information. It is a consumer-focused identity solution that uses JavaScript Object Notation, JSON, or JavaScript Web Token, JWT-based tokens. Let's delve into certificate-based authentication. Certificate-based authentication is an authentication method that uses digital certificates to identify users, machines, or devices before granting access to resources, networks, or applications. Key components include public key infrastructure, PKI, X.509 digital certificates, a certificate authority, CA, and certificate revocation lists, CRL. Certificate-based authentication has several benefits. It provides stronger security than password-based authentication, offers mutual authentication capability, and simplifies the user experience by eliminating the need for passwords. Now let's explore biometric authentication. Common types of biometrics include fingerprint scanning, which uses unique ridge patterns, retina scans, which analyze blood vessel patterns, facial recognition, which maps facial features, voice recognition, which identifies vocal characteristics, signature analysis, which examines writing patterns, and keystroke dynamics, which studies typing patterns. The process typically involves enrollment, where a biometric template is captured and stored, authentication, where a live sample is compared with the stored template, and match scoring, where the similarity threshold is determined. Consider that biometric authentication offers the benefit of convenience, as there are no passwords to remember. However, it also raises privacy concerns and requires careful data protection measures. It is also worth noting that false acceptance and rejection rates, and the risk of spoofing and presentation attacks needs to be taken into account. Finally, let's look at the future of network authentication. One major trend is passwordless authentication, which moves beyond passwords using fast identity online, FIDO, 2, web authentication, WebAuthn, and security keys. This eliminates password-related vulnerabilities and improves user experience. Another trend is artificial intelligence, AI-powered authentication. AI is used for behavioral biometrics and continuous authentication, analyzing patterns in typing, mouse movements, and application usage to verify identity. Another future technology is blockchain identity. Blockchain technology is used for decentralized identity management. Self-sovereign identity allows users to control their credentials without central authorities. Mobile-centric authentication uses smartphones as secure authenticators via push notifications, quick response (QR) codes, and mobile biometrics, leveraging the ubiquity of mobile devices for convenient authentication. Zero-trust architecture enforces a never trust, always verify approach, requiring continuous authentication and treating all network traffic as potentially hostile, regardless of source or destination. Adaptive authentication adopts a risk-based approach that adjusts security requirements based on context, considering factors like location, device, network, and behavior to determine authentication needs. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.